Hi everyone, hope you are doing fine. So again today I am going to solve the daily challenge problem of LeetCode, and after that I am going to solve like two three more problems. So I just see like first problem is like this palindromic subarray sum, and like the similar problem is like a longest palindrome substring. So yeah, this problem I have already solved, but I haven't solved this one. So yeah, so let's start with the daily challenge problem firstly. So today problem is I think yeah, is a easy one. So let's see. So the problem name is like concatenate non-zero digits and multiply by some yeah. So concatenate non-zero digit and multiply by some. So you are given an integer and form a new integer x by concatenating form a new integer x by concatenating the all non-zero digits of n in the original order if there is a non-zero digit x equal to 0. Yeah. Let sum be the sum of the digits in x. So we have to concatenate the all the numbers. So after concatenating, so it will look something like 1 2, we can say 3 4. Yeah. So x become this, and the sum of digit is going to be a 1 plus 2 plus 3 plus 4, that is going 4, that is going to be a 10, and therefore the answer is going to be 1 2 3 4 into 10. Similarly for this the sum is 1, and also a number is also 1, so it is going to be a 1. So yeah, it's quite simple. So we have to simply convert that number to another number. So we can do something like this, like string s equal to stu, like we can convert number to a string, and then we can iterate this string. So like int like it number, like number is going to be it minus, we can say 0, it minus 0. So if the number is not equal to 0, like answer is going to like the sum is going to sorry, sum, not sum, like x is going to be like x into 10 plus num, and yeah, is not equal to 0, and sum is going to be a num. So yeah, we have to define int x, we can say long x comma, we can say sum. So at last we can simply turn sum into x, I think. Yeah, let's try to run this. stoi, oh sorry, so stoi is the function to convert the number string to integer. So we have to do like something like toString function. We have to call this function toString. Output is this 1 1, uh, why 1 1. So yeah, so we have to define this, assign their value 0, so it is going to be some random value else. So I think now it should work, and so let's try to submit this. So yeah, today problem was quite easy. So let's move to the another problem which we are going to solve. So the problem is like you are given a array, like a integer array nums, and we have to return the maximum possible sum of a subarray of nums, that is palindrome. So yeah, so like in this the constraints are pretty high, like 10 raised to the 5. So the problem is like let's copy this. Like the problem is we have given some like some array of size n, and we have to form a palindrome sub, like we have to check a subarray with the maximum sum, but there is one extra condition, like we have to check whether it is a palindrome or not. So first approach is like we can simply make all the like all the subarray starting from 1, then from 2, then 3, then like something like that. So it is going to be n square to generate all these palindrome, and like a big of n to also to do like to check palindrome or not. So overall it is going to be a n cube, I think. Yeah, n cube. But we can do this thing like we can pre-compute the palindrome thing, but again in that also we have to do something like yeah, it is going to again going to be n square for palindrome checking, pre-computation, and n square for checking. So yeah, the time complexity reduced from n cube to n square, but again the constraints are pretty high, like 10 to the power 5. So again, it is not going to be able to pass all the test cases. So before solving this problem, we are going to solve the similar kind of problem, but it is for string. So we have to return the longest palindromic substring. So yeah, so I think it's a pretty standard problem, and everybody solve like whenever they are preparing for the interview. So yeah, let's start by solving like this. Take this example, BABAD. So we have to return the longest palindromic substring. So in this, the substring is BAB. So yeah, it's a pretty standard problem, and so the first approach is like similar, like that we discussed earlier. We are going to make like generate all subarray, like generate all subarray, and then try to check palindrome. Like to generate all the palindrome, it's going to be a big O of we can say big O of n square. Yeah, and to check palindrome, it is going to be a big O of n. So it's again going to be a big O of n cube. So yeah, this is not going to like in this case, like the constraints are like 1000 only. So this is going to this is also not going to work. But if we do some pre-computation to do this thing in like a faster way, like we do some pre-computation to check if the palindrome substring is a palindrome or not. So then we can simply do this thing. So let's see how we can solve this. So the first approach to solve this thing is like you have some like let's draw this. Yeah. So we have something like B A B A D. We have a string like this. B A B A D. So like this this represent 0 0. This represent 0 1. This represent 0 2 0 3 0 4. Yeah, 1 0 1 1 1 0 1 1 1 2 1 3 1 4 2 0 2 1 2 2 2 3 2 4 3 0 3 1 3 2 3 3 3 4 4 0 4 1 4 2 4 3 4 4. So yeah, so you can see like this part, the part below this line is a simply the opposite of this thing, like this. We are taking from 1 to 1 to 2. In this it is from 2 to 1. Again, like in this you can compare 2 3, like it's a 3 2. So we can completely ignore this like down part. We can say this part, this part, this part, this part, and this part. So we are going to ignore this part. So now like we like this like 0 0 mean, this 0 0 mean we are taking the subarray of size this. We are going to take the subarray of size yeah, subarray of size 0, like it is going to be this subarray. For 0 1 we are going to take this, we are talking about this subarray. For 0 2 the subarray is going to be this. For 0 3 the subarray is going to from 0 to 3. Similarly for let's say for 2 3 this 2 3 we are going to take the subarray this, like 2 3 this. Now for this 3 4 it is going to be subarray from this 3 0 1 this 3 to 4. So like we are going to check if is it possible to make this array a sub like is this subarray is a valid subarray or not. By valid we mean that if it is a palindrome or not. So yeah, let's again draw like a new matrix for this thing. So we have something like uh, we can see we have substring like this a size of 4. So by 0 0 like you can know the any substring of size 1 is going to be a palindrome. So like these are all going to be 1. So these all value are going to be a we can say 1. This is going to be 1, this is going to be 1, this is going to be 1, and this is going to 1, this is going to be a 1. So now how we can check like a substring of size 2 is palindrome or not. Let's take like we are checking for this BA. Then another pair is going to be a AB. Then after that another pair is going to be a BA. Then it's going to be a AD. Yeah, these are the pair. So like if the two value are same, it means that the this subarray is palindrome. So can a subarray from 0 to 1 is palindrome like this subarray, not palindrome. So it is going to be a 0. Again for like 1 to 2, like 1 to 2 like this palindrome. Is this palindrome? No. So it is going to be 0. It is going to be 0 again for BA also and AD also. So yeah. So for like subarray of size 1 and 2, it's a pretty easy. Like for a single, it is going to be palindrome. And for this two line subarray, if the both values are going to be same, then it's a palindrome. But how we can check for a length of length of size 3? How we can check? So let's say we are taking example for BAC. So it's from 0 to 2. So from 0 to 2, it becomes something like BAB. So if we know already, if we have already calculated the answer for this thing, so by comparing the last two value, we can check whether it is a palindrome or not. So like what is the middle value? Like in this case, the middle value A. So middle value is going to be this value only. So you can see like this is from 0 1 to. So the middle value is from 1 to 1. So yeah, so you can see this subarray represent the value 1 to 1. So if this is true, like if it is this true, 1 to 1 value, yeah, it means that this is true. So and this value B and B are also same, it means that the subarray is palindrome. So we are going to make this one. So yeah, so what this like this DP array represent like for 0 to 2, if is it possible to make like is this subarray palindrome or not? So yeah, it means the palindrome, so we are marking it as a 1. So again we move from ABA. So we are checking sorry, not ABA. Yeah, let's say this from 1 to 2. No 1 to sorry, not 1 to 2, like 2 to 3. So this is something like 2 to 3. I think it should be from 1 to 3, sorry. Not 2 to 3, 1 to 3. So 1 to 3 is like ABA. Again ABA. So we check like if the middle part is palindrome. By middle part we can simply do something like check for this. Is it palindrome? Yeah. Again it means that and the value are same. It means it is a palindrome. So now for BAD. BAD. That is from uh 2 to 4. 2 3 4. Like if this last values last and the first value are same, no, but the middle one is same, so it means that it is not palindrome, because for a palindrome whole substring should be like reverse should be a same. So yeah, it is going to be 0. Then for length of size 4, BABA. BABA. So this represent from 0 to 3. So this is substring from 0 to 3. Like is the middle value is palindrome? No. So no need to check the last value. Again for from 1 to 4, ABAD. You can see the last value are not same. So it is going to be a 0. Again for the whole string, like last values are not same, but you can say middle are same, but you no but it is not going to palindrome because the last value should also be same. So yeah, we are going to write here 0. So you can see we get like we make this subarray. Now we can pretty easily check for every subarray. Like if we have to check from like subarray from 0 to 3, is a palindrome or not? If is it palindrome 0 to 3, if the value is 1, it means that the array is palindrome. So we can do something, yeah, we can do this thing, and again we get some palindrome number. Yeah, so it's a pretty standard problem. So I am not going to be write the code for this. So let's see, like this approach will easily pass in this test case. But if we open a CSC problem set, yeah, CSC. In this problem set, we have also have a same problem like this. Let me log in here. So yeah, I am not getting any mail, but I think the name is same as this. So let's try something else password. So yeah, let's see. Now the email come. And so yeah, we can reset password. So yeah, now it's work. Let's see. So yeah, it's working now. So let's see the string section. So yeah, like what is the problem? I think the yeah this so this is the problem longest palindrome. So you can see there the constraints are pretty high. So yeah, so we are going to solve this problem for this constraint. So how we can check this? So for this so I have already solved this problem. So for to solve this problem, you have to know a special technique. We can say special algorithm known as Menacker's algorithm. I think Menacker's, yeah, Menacker's algorithm. So by doing this, we can find all these sub palindrome in big O of n. So yeah, so you can see you can see you can read if you want to read. You can read from this section how to solve this like what uh about this Menacker's algorithm to generate all the palindrome. And so if you want, uh, so if you want like a good resource, a good video resource to solve this about this to learn about this Menacker's algorithm, you can watch Vivek Gupta. Yeah, Vivek Gupta Menacker's algorithm. So yeah, so it's a pretty like a good problem. In this video, the Vivek has explained the problem like in a very good way. So you can watch this video to learn about this. So yeah, so let's see how we can what is the main idea behind this algorithm. So like the main idea behind this problem is the algorithm is that uh let me take some example, some big example. A B A C A D E F G H. Yeah, we can say. So the main idea behind this problem is like if we find some like if we take some like a substring like this, if this is a palindrome range, then again like from the subarray between subarray in the range, these are also going to be a like a palindrome. So yeah, I am not exactly getting the like. Let me read again about this a little bit. So so yeah, so let's read again this. Give a read to this. So given string as with the length and find all the pair I j such that I and j is a palindrome. String t is a palindrome when the t is going to be a reverse of t. Yeah. So in the worst case, might be a big offense scale. At the first glance, it seemed that there is a no algorithm to do this problem. So, but so yeah, let's see the solution. So the what is the trivial solution is like to avoid ambiguity in further discussion, we denote what tribal solution algorithm is. It's the algorithm that does the following. For each center position, I tries to increase the answer by one as long as it possible, comparing a pair of corresponding character each time. Such that the algorithm is slow, it compute answer in big of n square. So they are doing, they are telling us a same like a bit better like a trivial algorithm how we can solve this thing. So they are saying we have something like this string. Yeah. So at every step, we are going to expand in the left and right. So if we are standing at this position, we are going to expand from this like, so we are going to expand this string. Like this is like single part is palindrome. So we check if the left and the right is palindrome or not. So it is not palindrome. So let me write it is in a proper way and take some good example instead of some random character. Let's take the example they are taking. Is they taking an example? Yeah. A B C B C uh, A B C A B C B C A uh B C B A, sorry, B C B A. So this is a, so what we are going to do, we are going to expand from every character like every digit. So we are going to expand from this. So we are going to expand from this like how many palindrome maximum palindrome substring we get from this size. So for this it is going to be one only because it's a like this thing is palindrome for this A. So for B again we can't expand in its left and right. So B is palindrome in itself, and but if we take A and C, these are going not going to a palindrome. So it again it is going to be one. So for C, if we check for C, you can see like this C is palindrome, and again its left and the right are palindrome. But after that, they are not palindrome. So again, here we get the three length substring. Again for this B is equal, and then this C are also equal. Then this B are also equal, and this A are also equal. So in this case, we get the answer as 4. And for this C, the answer is going to be something like 1 for this and 2 for this. So it is going to be 3, and for this B it is going to be 1, and for this A this again is going to be 1. So by doing this we can make this subarray. So again by doing this approach, the time complexity is going to be a big of n square only. So the main idea is like how we can optimize this thing. So in this what we are doing, let's try again it in like, so I can explain it is in a better way to take a complete example. So yeah, so we have something like this A B C B C B A. So we are taking this B as a center. So from here we try to expand in left and the right. So we move to one step left and one step right and compare this value. If these values are same, it means that the substring is palindrome. Again, we like if it is a palindrome, then again we try to expand. Again we try to expand. Then again B and B are same. It mean that the substring, this substring is whole is palindrome. Then again we move to left and the right. again it is palindrome. Then we will try to expand, but let's now we can't expand like further. Let's say assume there is a c present here also, but we can't expand it left, so we can stop. So in this case the maximum substrate length is like this is going to be a not 4, it's going to be a 7 only, sorry 7, because 3 from left side, 3 from right, and 1 from this 7. So but in this case, in this example we are missing the one case. So if we have something like let's we have something like example like this, CA. So if we take, in this case we are not taking anything as a center, we are taking this like this BB, now this AA, and then CC, and then this AA. So this is also palindrome, but by doing our approach, we can't get the max answer. Like in this, the answer is going to be a 8 length substring. So by this approach, we will not get. So instead of doing this, so to the better way to do this thing is like we have to either we can iterate like first like this, and then again do by by taking like a two variable thing. So we are going to take this first two, then again this second two, like this. So instead of doing to like this, they suggest us to adding a hash value. So they suggest like you can add hash everywhere, like before the substring, and every character after substring, and at the last. So after that our like string will look something like this. So it's it's a B, then it's going to a C, then again hash, then it's going to be B, then again hash, then it's going to be a C, then again hash, it's going to be B, hash, A, yeah, and at the last we are put a hash. So by doing this, we are like this case is handled, like this case is handled, so we have to do something special to handle this type of case. So in this case, if we take something like hash as a center, then we are taking this as a substring, whole substring. So yeah, so in this so we are like hash will match, and again we have to do like we can check like like in a way we are checking for this thing. So it's going to be pretty same for that. But you can see so let's define this again, draw this array for this thing. So it's going to be something like hash A, hash B, hash C, hash B, hash C, hash B, hash A, hash. So yeah, so let's define the index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah, I think 7, like the substring length is 7, and the 7 into 2, 14, and at the last it's going to a 15 length. So but you can say like in this we are making the string length as like 2n. So yeah, like in this the 2 is a constant, so it is not going to affect our time complexity, we can say a lot. So like it's a very like minimal thing. So it's going to be a very minimal, so we can do like this, so that we can, like if we do something like this, then we have to do again two iterations, so not it will not affect the time complexity a lot. So yeah, so let's try to make this as now, like calculate the answer for this, because the main idea is by how we can optimize this thing. So we have to find some pattern to do this thing in a better way. So that's why I am again drawing the like making this same thing again. So yeah, so for this approach, I am also going to write the code for this thing. So for a single like for this, the hash is going to be a match, and further we can't expand these things, so it is going to be a one. So for this it is matching, and for again we try to expand. So for this we get answer as 2. So for this again hash are matching and not matching, so 1. B is matching and hash is also matching, so we get answer as 2. Again hash is matching, B and C are not matching, 1. For C, this is going to be a 1, this is going to be a 2, this is going to be a 3, this is going to be a 4. So it's going to be 4. Again for hash it is going to be 1. For b it is going to 1, 2, 3, 4, 5, 6, 7 and 8. It is going to be 8. And this for hash it is going to be 1. And for this c it is going to be we can say 1, this 2, this 3 and this 4. 4. And for this hash it is yeah, for this hash it is going to be a 1 only. For this b it is going to be 1, 2, 2 only, we can say. Yeah, for this hash it is going to be 1. For this a it is going to be a we can say 2. For this hash 1. So yeah, I think it's pretty much 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have missed something, I must say. For hash it is going to 1, then for 8. So yeah, so we get the main idea behind thing. So we can skip this thing for now. We can say for this what index of 7, 0, 1, 2, 3, 4, 5, 6, 7, 7. Then again for this 2, this 3, this 4, this 5, this 6. So yeah, so we have not this thing. So yeah, this is only the sorry, this is not like we can say there is nothing value like this. So it's a correct, we make the correct thing. So you can see like there are something like let's say again check this so you can see like we have something like for this substring starting at this b and this and that this whole substring, this whole substring. So after that so you can see that the we get some big value like a large substring, we can say large substring. And after that we have like something like same, we are just copy pasting this thing, like you can see this thing, and again this thing is copy paste, again this thing copy paste, again this thing is copy paste, again this thing is copy paste, you can see this thing is also copy paste. So you can see there are a lot of like similar thing we can say, or we can say yeah, we are just copy pasting this, like we are getting same answer which we get previous. So this is the main idea. Now we are going to optimize this thing. So before optimizing this thing, so let's the write the code for this thing to get the better understanding. So yeah, uh so let me copy the template. Yeah, template copied. So we have something like we are not going to take this, we have something like string, we are going to take input, and we have something like we can say a function like string function which is going to be returned the so we can simply take a string as a in a function, and now we are going to simply do this thing. So what we are doing was, so firstly we have to add a hash to the string. So we can simply make a function to do this thing. uh so we can make it as a new string a function, so which is going to take a string of size as a string s. And yeah, so we are going to take a string t, and we can simply iterate, and we can simply t dot push back, we can simply add hash at starting, and then we can add hash at a end, and also we have to push the value to our this like whole value to t. So yeah, I think it's pretty much done. So yeah, we get our the new string which we want. So we can this as string t, or we can say that s is going to be a new string of. So yeah, we also need a required a previous string to calculate stuff like if it this range is polynomial. So we are not going to change this. We are taking making a new variable name as t and going to call this function name new string and pass the s to it. So yeah, we get our new string. So it's so we can simply remove this size we can say variable, And after that, what was we doing? We are iterating from I equal to 0 and I equal to n I plus plus. We are iterating this loop, and for everything we have something like left equal to I minus 1 and right is going to be a I plus 1, and we have to make this a, let's say we are making this as a dp of n comma initially so like all value are going to be 1, so we are initially making our value as a 1 in our dp, so we can check. So yeah, so we have to check if the left value is greater than or equal to 0, we can check, and also the right value must be less than, we can say, n minus 1. So if it is true, then we can check this thing. We can check this thing if the values are not equal or not. If s of like s of left equal to s of right, sorry, so s of left equal to s of right, we can increase the count. So initially count is going to be a 1, we can say yeah 1, and after every we increase the count by 2 because one from left and a one from right, or we can simply increase the count by 1 only. So I will yeah. So like if we are moving to left, we again get 1 2 3 4 5 6 7 8, 2 3 4 5 6 7 8, yeah. So we are increasing the count by 1. So yeah, that's pretty much, I think. So like if the value is same, so we have to do until the like if the value are like value are like value are less, and we can simply write here only, and s of left must be equal to s of right. Then we can simply do count plus plus and increase left decrease left value by 1 and increase left value right value by 1. So yeah, so and at last we are making the dp of I is equal to count. So now let's print our dp array which we get. So our string was a b, I think that was our string, I think, yeah. So let's run. Oh yeah, we are so we have to call this function also, function of s. But we are getting a wrong value. Left is going to be I minus 1 and the right is going to be I plus 1, while left is greater than or equal to 0 and the right is less than n, and s of left equal to s of right, count plus 1, left minus 1 and the right plus 1. So why we are not getting this thing? So it is going to be sorry, not s of, it's going to be a t of, we can say, yeah. But again we are not getting the answer of 7 8 here. I think we should get the answer of 8 here. Cause let's print our string t, c of t. So if we starting at this b, this is going to 1 plus 2 3 4 5 6 7 8. So yeah, if less than, oh sorry, it's going to be less than or equal to n minus 1. My mistake. So yeah, so we get pretty much same array, I think. So let's see. So we get something like we can say 1 2 1 2 1 1 2 1. Sorry, this is going to be A B. Sorry, it's a C, not A. So we have something like C here, C here, and a C here. So yeah, let's run it now. So you can see that we get same array 1 2 1 2 1 4 1 8 1 4 1 2 1 2 1. So yeah, so let's read about now the what is the optimization. So this so we understand the trivial thing, and so we describe the algorithm to find a sub palindrome with all length. That is, yeah, we are doing this something like a right most of palindrome. So if he's outside the current sub palindrome, that is, we just launch the trivial algorithm. So we decrease the I, and now we have something like palindrome. So yeah, so like if the I is so let's read this thing. So so yeah, I get this thing. What are they trying to say? So let's start with this thing. What happened after that? So now we have similar like let's copy paste this string from here only. So yeah, we have something like this. So now what we do? So like we are going to expand this thing. Like we are starting from the like what we are doing here is. So we are trying to expand in the left and right. You can see like expanding in a left and right direction. So let's say we are at this position here. For this, uh, for this we are expanded for left. It's left and it's right also. So if we are at this, our answer is going to be 8. Like you can see, like for B, the answer is 8. We expand in our left and the right. So in this case, our left is going to become something like we can say. So yeah, so our left is going to be a something like at a 0. Left is going to be a 0, and the right is going to be it's going to be a at 14th index, we can say. Yeah, I think this is so yeah, 15 line string. So index is going to right is going to be at a 14. So yeah, you can see that we have already pre-computed this thing. So for this we have expanded this thing. So for this we can say like if we are starting at this index. So like for this if we are starting from traversing from start, we have already processed this thing. So yeah, let's write the answer for this also. One white is removing. So yeah, so for this answer is also going to be firstly we have calculated this thing, then afterward we have moved here. So now we have moved here. Our low is at 0 and the right is at 14. So for this, like we can check. You can see the answer is 1. So answer for its same value is going to be 1. So we can simply write here 1. Now I will explain why we are writing. Because like if this is like if starting at this index, the left is palindrome, it means that this is going to be same for this thing. Like if they are palindrome, it means that the value at this index and this index is going to be the same. So if they will try to expand this thing like this, they will try to expand in a left and the right, this the value is going to be a same also. Like you like if you are starting at this index or starting at this index, if the whole thing is palindrome, then it is going to be a same only. Yeah, but the main problem, yeah, you can see for this also the 4. So if we are starting at this index and the what is the we add 4, it means that the whole substring from here to here, and here to here is same. So like again it is in our range left to right. It means that we can simply put 4 here. But let's add some value, something here, like new value here also, so that we can so I can explain the thing what I what we do in this. So let's say for this b, the value is hash hash hash. No, we can't do something like this. mm, so for this b we will try to expand like this b. So yeah, let's say here is the c value and here is also c value, and then this is going to be a b match, hash match, c match, again hash match, again we have something like b here, hash here, c here, hash here, b here, something like we can do b, then we have something like hash, then c, then we have something like hash, then b, then something like hash, then c and hash. So now you can see like for here the answer is going to be 4, and but for this hash what is the answer? For this hash the value is going to be this value like correspond to each other. So yeah, the answer is going to be 1. But for this b the answer is 2, not 2. Like for this the answer is going to be a 1 2, like we can say this match, and now this c also matches. So the answer is for this is going to be a 4. So we can say we can simply write the 4 here also. But yeah, but when you write the 4 here, you can see like what happens. We are moving out of range, like 1 2 3 4. We are at, or we are already at this right equal to 14. So this was our 14 index, this is our 15 index, like we can write our 14 15 16 17 18 19 20 and 21. So you can see we are already at this thing. But you can see there are some values in the so there are some values, like you can see if we are at this where are we at this b, we are at this b. So here the 4 length is palindrome, like you can see this 1, this 2, this 3 and this 4. But in this case after this 4 there was no value in the left side, but in this case there are some values in the right side. So we will again try to expand this thing. So now our 4 length is palindrome. Again we check if this 5 length is palindrome, then 6 length, then 7 length, then 8 length, then 9 length, then 10 length. Similarly like 11 we can say, not 11, I think for here we get 10. So this is matching, this match, like let me change the color. So this b is match, this hash are matching 2, this c match 3, this hash match 4, this b match 5, this hash match 6, this c match 7, this hash match 8, this b match we can say 9, this hash match 10, this c match 11, this hash match 12 we can say. So we are getting the 12 here. So again, so like but from here what we are thinking, what we like we come to observation, like if the answer is going to be in a range, like if the high is this, like this value subarray and is going to be in this same range like this of high, then we don't need to expand this thing. But if it is greater than that, we have to expand this thing. So in this case, the if we reach to the end, but there are a left and a right value, so we are going to expand as much, like we are going to expand as much as possible. So yeah, so this is the main idea behind this thing. So yeah, so it's a pretty much like the so after that, like it's think you think like it's a lot, but no, it is not going to be a lot, because we are expanding in a left and right only once, and after that we will only expand if the light and the left values are going to be increased. So if so at every moment if we have processed that much right, we are not going to expand like further check for that thing.
we are again further trying to check from its last value, we can say last and greater than that. So in the worst case, the time complexity, like we have to iterate for big of n thing, and in overall we are moving again big of n. So it's going to big of n plus big of n, like a 2n. So yeah, so as the 2 is a constant, we can remove this. So again, we can solve this problem in a big O of n thing. So let's write a code for this thing so you can understand it in a proper way. So we can also keep this code to compare the answer. So we are going Manak's algorithm, and we are going to take a string as uh so in n is going to be s dot size, and then we have to do something like so we have to expand that thing. So initially left is going to be our 0, we can say, and the right is also going to be a 0. So yeah, so we are starting from int like int I equal to 0, I less than n, and I plus plus. So string t is going to be a new string which we are getting for that. We are passing as here. So size is going to be this size, we can say. So yeah, one thing more. So like for this the answer is not going to be 8. For this the answer is going to be a 7 only. You can see like for if we take you can see, because we are adding hash, like hash as starting and index also. So there will be a one extra match. So we, if we subtract one from this thing everywhere, so we will get the exact answer. So yeah, so that's it for. So like in case of this hash, if we remove minus like add -1, it becomes 0, because like if we choose these two element, they are not equal, so we get that thing. So yeah, that's it. So yeah, so we have something, so we iterate from 0, and we have to make make a dp array, we can say int vector of dp of n, and initially we can say all the value are 1. So how now the main thing is like how we get this thing, like we are comparing like if we are at this 8, that it is this is I, like this is our middle index, we can say, and this left is 0 and the right is at 14. So for this like this I value, how we get this previous j value for like this value are same. So it's a pretty easy formula, like so we have something like left as 0 and the right as 14, L as 0, right as 14, and we have something like this is 0 1 2 3 4 5 6 7. Yeah, this is 7 index, this is 8, this is 9 10 11 12 13 14. Yeah, 14 like yeah, it's correct. So we are at index 8, so we have to find the mapping for 8. So the form I think so what we are doing, we are going to do r l plus I is going to be a 0 plus I 8, 14 minus 8. What is 14 minus 8? 14 minus 8 is going to be 6. You can see we get this matching. So the formula is going to be a like L plus I minus R minus L plus I. So yeah, so it's a simple formula. So like index is going to be a right minus left plus I, we can say. So yeah, so that's it. So if the now we have to check like so this is we get this index value and the left and the right also. So in the case of 0, like it's going to be right. What is the right? Right value is 0, and the left, what is the left? Left is also, we can say 0 plus I is also 0, so it's going to be a 0 only. what happen is like if the values are in a range. So if the index is less than, so initially if the index is less than or equal to right, so it mean that the dp of what we can say that count is going to be a dp of index only. So we are just copy pasting this previous value, like if the value is in less than range, we are copy pasting this thing, and we can say the dp of index become count. But again we have to check whether there may be possibility like this is going to be a last equal to last value. So we now need to check if the this value and the further values are equal. So we will check like so the left is going to be a this thing, we can say. So yeah, left is going to be pretty much same, we can say. So let's say int we can define a j equal to j as I, and index is like index we have already have. So like while so we can do something like j plus plus, sorry, yeah, I plus plus, and int index is going to be a index minus 1, and j is going to be I plus 1, we can say, yeah. So after that we will check like if these values are in a range, like if I index is greater than or equal to 0, and j is less than equal to less than yeah, if it is less than n. So we can check if the like as t of I index and t of index is equal to t of j, it means that it's the same. So we will try to expand this thing. If we have to try to expand this thing, so we do index minus 1 and j plus equal to 1. So yeah, that's it. So in that case the both the index and the j will increase. So we will check like if the index is less than left, so we left is going to be a index. And also if the, so we can say right is going to always be a greater than the this thing. So we can also write that something like that also. But we can simply also check like if the j is greater than or equal to j is greater than right, we will mark this as a right, j right equal to j. So that's pretty much, I think it should let me check we are, are getting the I value, and if the I is less than this thing, then it's going to be 1. Let's say it's going to be a so yeah, else like we can mark it as a 1 value, because there may be a possibility of one always, because we are taking single thing, like if we are taking this thing, this is going to be 1, and after that this is going, we are trying to find next thing. So that's why I'm taking count as 1. So yeah, so let's try to now print this thing, our dp array. So we can also call these functions Minecraft algorithm and pass same as. So yeah, let's run this. So we are getting into idx minus equal to 1. So yeah, so we have something like, so we can't redefine this thing. So we are getting string. So it's not, so it's going to be a smaller s for string. So yeah, let's see. So yeah, we are getting the wrong thing. So let's see. So for everything we are getting as a one answer. So let's see why we are getting one. We are something like we are what we are doing. So let's need, see out this j and I. We can say I as index and j as this j. Yeah. So it's always minus one. Index minus one. So yeah. So instead of doing this again, doing this one again initially, so we can simply define this as equal to one, not one. We can define in index at index only and j as I only, so that for single value we also get the same thing. So let's see out. So let me run this thing and again check. So yeah, we are pretty much getting the things. Uh, but at last we also have to update dp of, we can say, uh, so we can simply maintain increase the count value always here also, and at dp of I is going to be a count at last. So yeah, so initially count is going to be 0 then. So again, so I think now it should work. Let's see. So for so instead of I, we can simply mark this as index idx and also see out I, and left and right also, left and the right also. So initially the index is left is 0 and the right is 0, and after that so we what we get as a count at the end, see out count. Count is 2, we are getting count as 2. How is it even possible? Like if we are at a 0, our index is 0, we can say, and j is 0 also, then we do j plus 1 and index do minus 1. After that it is not going to be same again, so we are already done the count plus 1. uh, dp of, we can say, index is going to be this. Not this, yeah, dp of I is going to be a dp of index. Index is 0, j is 0, j less than, and t of index is j equal. So the count is 1 for the one value, so it must be a 1 only. So why we are not getting this like For this I we are updating it as a with count now. So you can see that for I equal to 0, the count is 1. And after that we are not doing anything. So in the middle, the value of dp of I is changing. So yeah, we can skip this thing. So yeah, so now the value are getting changed. So let's see. So at so after first position, the left is 0 and the right is 0. So for second, the left is going to be a -1. Mm. So what we can do, like we can't do something like if the left is max of index comma we can say 0. So what is the value of index? Index is 0. Index is -2. Index is -3. So like how we can handle this case? So if the value is out of range. So we can say like idx must be max of index comma 0. I think we can do something like this and then check. But again, we're not getting the expected answer. So let's see how they write the code. So yeah, let's see this code here. So what they are doing, like they are checking. So instead of doing something like a lot of thing, they are simply checking, doing something like this. We can say we can also do some similar like this. So they are checking from I equal to 1, and initially they are what are they assigning the value like 0 and 1. They are assigning L 0 and R as 1. So yeah, but I think so yeah, let's define the value as 0 and 1, and now we will check. So if the I is less than or equal to, say we can say R. So yeah, if it is in a range, then P of I, like a dp of I is going to be a, we can say, minimum of R minus I, because like the max difference between R and I, like we can't take, like there may be a possibility like there are lot of values on the left and there is only less value on the right. So that's why for that, and actual it going to be a max of dp of the same thing we are doing, like L plus R minus I, sorry. So yeah, we also write this the formula as a wrong. So it's going to be L plus R minus I. So if we are at like 0 1 2, we can say 0 1 2 3 4 5 6 7 7 8 9 10. If we are at 8, if we are at 8 and our k is like and is 15, and is 15, not 11 12 11 12 13 14. So and is 14, and start is, we can say, 0, and index we are checking is the 7th, sorry, 8th. So for 8 it is going to be a start. What is L? L is going to be a left like a start, 0 start plus 0 plus R minus L, 0 plus what is R? uh R is going to be 14, 14 minus 8 is going to be a 6. So yeah, for this the value is going to be 6. So yeah, so you can also drive this thing, or if you solve problem like 2 to 3 times, so it will you will easily get this thing. So yeah, so if it is equal, then okay, then we will check like if S of I, why I minus dp of I must be greater than greater than equal to 0, and I plus dp of I must be less than n. And if the S of I minus dp of I equal to, oh sorry, not S, it's going to be a T, and a T of I plus dp of I. So if the value are going to be same, we going to increase the dp of I value by 1. And at last we check if the I plus dp of I is greater than R, then L is going to be I minus p of I, we can say, and R is going to be I plus p of I. It means that dp of, in our case. So now let's try to run this thing. So it's going to be a left. This thing is going to be a right, left, and right. Let's try it now. Again, we have used R somewhere. Again, I plus. We have 61, line number 61. We have I must be less than right. And then we have something like dp. We are assigning some value. in line number 62, it's going to be a dp of I is going to be a, again we are it's going to be a right here, and also semicolon at last. So I think, yeah, we get the same array. So it means that this code is correct. So let's now try to understand how what we are doing in this again by taking this example. So yeah, so instead of copy pasting the code, we can simply take the screenshot of this code and then add this here. So yeah, so firstly, if we have something like a hash b, sorry, it's going to be a hash b hash a hash b hash a hash. So let's say we are at initially we are at this, for this the answer is going to be 1, so we define this. So now we are going to check for this, and now initially the right is going to be at left is going to at 0 and the right is going to be at 1. So we can check if the left and the right right is in this range. Yeah, the right, like you can see that I is in this range. So if it is in this range, we can check like if I is less than or equal to right. So in this case, like what is the mean of right comma I? Right is 1 and dp like index is I 1. So it's going to be I minus I. So yeah, it's become 0. So in the both of in this case is going to be 0 only. So it become the answer for dp of I becomes 0. And at this case, the I minus dp of I is going to be I, and I plus dp of I is going to be a same, like a same index. So the value is going to be same and do index plus 1. So we move to like we mark this as a dp of I equal to this as 1. Again, this value is 1. This is also going to 1, and move to next. And now again our now right, like this value I plus dp is greater than right, so right become this 2. Again we move to next. Again it is going to be a same for this thing. So like after this thing, they will the array will expand. So the array will expand, so it will look something like this. So right will be going to be a step next to this, and the left is going to be at 0. So yeah, right is going to be at 2 and the left is going to be at 0. Then again we will try to like expand, but we reach the end. So yeah, we skip this part. So for this the value is going to be a 2. So for this hash again, like you can see this come in a range, and after that the next values are not same, it is going to be 1. Then for this b value the answer is going to be a 4. So yeah, so that's a pretty much like a like code is quite easy. Like you can see like you have to only drive this for one formula. So yeah, the formula is like if we have something like 0 to k, and a k is always going to right is always going to be a plus 1 in our case. So for that answer is going to be a, so let me print this right thing. Like what is the value of right in case of see out left left comma right, and also print index also. So we get at which current index we are at. So for index 7, the left yeah. So for this we have to check. For this 8, the left is going to be -1 and the right is going to be 50. So like both the value are going to be like one step greater than the range. So yeah, so like if the one like so if we are at 15, if we are at 15, L is going to be a minus 1 plus 8 equal to 7, and then like we can say something like left plus right minus I is going to be a right minus, like we can say 15 minus minus 1 minus 1 plus r minus I, 15 minus I, 15 minus 8 is going to be a 7, and 7 minus 1 is going to be a 6 only. So we can simply left plus right minus I is going to be a formula. So after that, that a simple thing. So now we get this thing. So now how we get this length of the substring? Because like you can see the length of longest substring. We get the length of longest substring, but what is the substring? We don't know exactly, because we have changes the mapping for this thing. So what we have now, like if we have something like A, B, C, B, A string like this, now we have, now after some like after adding hash, we our string looks something like this. So how we can check like if this substring in the like this range is palindrome or not? So let's define the mapping, how the mapping will look like this. Like this is 0 1 2 3 4, 0 1 2 3 4 5 6 7 8 9, going to be a 10. So yeah, so it's going to be a 10. So let's define now, uh if we are checking for 0, for what position we are checking. So like for the answer, we have to do minus 1 for, because we are taking some extra thing, because we are also including our hash in our answer, so that's why. So yeah, so 0 will going to map into like 0 will map to 1, you can see, and 1 will map to, we can say, 3, and 2 will map to, I think, 5, 3 will map to 7, 4 will map to 9. So you can see the mapping, like it's going to be a 2 into I plus 1. So in case first, like if the index is 0, the our subarray answer will store at 2 into I plus 1. So like what is 2 into I plus 1? Like we can say 2 into 0 plus 1 is going to 1. For 1, 2 into 1, 2 plus 1, 3. For 2, we can see like this. So yeah, so if we are getting for 2, if we are getting for 2, let's say, yeah, for the, yeah, for this 7, for this 7 the answer is like for this b, for this b the value is 7. So for this 7, the actual value is going to be 7 divided by 2, that is going to be 3. So it's going to be a like I minus 1, we can say, to calculate. So reverse is going to be something like I minus 1 by, like if we do 3 minus 1 divided by 2, we get this thing, I minus 1 divided by 2, 5 minus 1 divided by 2, 7 minus 1 divided by 2, 9 is minus 1 by 2. So yeah, we get something like that. But how we get like, so if we are checking for this hash, like this hash equal to 4, we are taking this subarray like hash equal to 4. If we are checking about this something like we can say yeah, this subarray, this CB, uh, if we have something like CC here also, then it's going to be a CBA. So yeah, so for this C, the subarray is going to be this, and then is going to be this. So far, see, like we have something like A, B, C, C, B, A. So hash will be hash A, hash B, hash C, hash C, hash B, hash A, hash. So it's going to be a something like 0, 1, 2, 3, 4, 5, 0, 1, 2, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think I have done something wrong here. So for the mapping of 3, this 3 is going to map at something like 6. 3 into 2, 6 plus 1, 5, 6. 3 into 2 plus 1 going to be a 7. So going to be a mapping at a 7 like this. See, but not I think so, like 0, 1, 2. So like this is 2, sorry. 0, 1, 2, 2 into 2, 4 plus 1, 5. So yeah, the mapping is for 5 here. So but again the problem is like how we can check like something like subarray from 0 to 4 is palindrome or not. 0 to 4 is palindrome or not, this subarray. So we get like what is the maximum length of this subarray, palindrome, maximum length palindrome subarray thing. But how we get for something like this? Like A, B, B, A, hash, A, hash, B, hash, B, hash, A, and hash. Now for this the answer is going to be 1. For this answer is going to be, so let's define indexing 0, 1, 2, 3, 4, 5, 6, 7, 8, 0, 1, 2, 3. For this the value is going to be 1. For this value is going to be a 2. For this 1, this is going to be a 2 only. For this hash the value is going to be a 1, 2, 3, 4, 5 only. For this 4 the value is going to be a 2 only, like 1 and 2. For this hash the value is going to be 1 only. And then for this a 2 and a 1. So how we get the length? So first thing is how we can like solve two problems. Like firstly to check if the like from a range A to B is palindrome or not. Range A to B is palindrome or not. Or second one is the longest length substring. Longest length substring. So to find the longest length substring, so the actually it will look something like this because we have to subtract one from that case. So we it will look something like this. So yeah, so you can see like at this 4, we get the maximum palindrome length. So how we get the length of this 4, like so in case of, you can see like in case of odd number, the length is going to be a same like like say like you can say in the number of case of odd length. So let's we are starting at this index as 3. So the length is So let's take this example, a b a b a. So for this the length is going to be a 5 only. So if we are going to try to expand this thing, so what we can do, we can divide it by 2. So we get answer as a -1, like it's we go because we have to subtract -1 from this only, and after in this case we will always get the length as a yeah, even only. If we subtract -1 we get even length because the length is always going to be increased by 2 if they are going to be the same because due to hash. So we have like something like 4 comma 4 like 5 divided by 2, which is going to be a 2. So the our start index is going to be something like first we have to map this index. For that mapping we do something like so let's define a string only, hash a hash b hash a hash b hash a. So it's going to be something like 0 1 2 3 4 5. So 5 divided by 2, 5 minus 1 divided by 2 is going to be a 2 only. So we get the mapping of that 2, and the value is going to again from 1 like 2 from left and the 2 from right. So left of 2 is going to be a 2 minus 2 is going to be a 0, and the right is going to be 2 plus 2. It's going to be a 2 plus 2 like a 4. So you can see like this is the length of this substrate. So yeah, so this is the one thing. So yeah, so in this case we have to do something like this only. Yeah, length of the so yeah, we have to find the longest length palindrome. So yeah, let's solve this thing now. So how we can do something like so from here we can simply we can say yeah. So what we can do. So yeah. So to answer the length of longest palindrome substring, we can simply traverse this thing like this DP array, and after that like we have to do int I equal to 0, I less than and I plus plus. And if like so we have two cases like even and odd. So in case of odd it was simple like so in case of odd it was like a simple thing if the value is like something like we can say odd. But in case of even we have to do like so in that case like for this like 4 we have to divide by 2 only, like 4 divided by 2 is going to be a 2. So we get at the second value, so we can get like 2 value, and it's going to be a 2 minus like uh 4 minus 2 is going to be a 2. So we were left with the 2 divided by 2, that is going to be 1 from left and the 1 from right. So it is going to be something like this we already chosen, and this left and the right. So yeah, so like if the I modulo 2 is going to be a 0, so it means the even length, and else is going to be a uh, right length. So like int value is going to be a dp of I, and it's going to be a minus actually -1. And in case of odd length like int start is going to be a we can say so int start comma, and we can say so initially we can say one length sub we get maximum is the one length palindrome 0 comma 0. We start at 0 and end at 0. So int size is also going to be a 1. So if and we also want to do the like if if the value is less than our current size, then we can simply continue, and else we will continue take this thing, and else we take this size is going to be a value again simply here. and start like in this case, in case of sorry, we can say odd number, start is going like int mid is going to be a dp of we can say value divided by 2, and then start is going to be a mid minus value divided by 2. Yeah, exactly this, and is going to be a mid plus value divided by 2. This is going to be, but in case of right, the mid is going to be a we can say I divided by 2, and in mid we are going to we add like mid is going to be a next value of the this thing. So the start is going to be a mid minus we can say value divided by 2, and is going to be a mid minus val divided by 2 minus 1. So for this the extra thing we are doing because we are already at this thing next mid next value, so for that we are doing this thing. So yeah, it's pretty I think it's done. So we can return as dot substring of size like as dot begin comma begin plus start comma, and I think it like the formula for this thing is similar like this. Uh, so yeah, so we have to pass size comma start thing comma start, and we have to pass something like size here on, we can say it's pretty much, or we don't need things. So let's see now if it is working. So yeah, I think now it's working. So we are getting empty string as our answer. So yeah, let's see the syntax for position and the length. So yeah, so I was pausing in a wrong way. So it's going to be position start comma size. So yeah, we are getting this thing. So let's try to check for other cases also. Uh, so I think yeah. So you also need to copy this function name as a new string. BABAD. So yeah, let's define something like this for testing and then check where we are getting an error. I think error is something else. BABAD. BABAD. We are getting answer here and we are getting correct answer also. So let's define this thing. Overflowed. Let's stop this thing for some time. Comment this thing. Test web code only. So I think we are getting error something here. Like we can do something like this. So it means that we are getting error in something like this. Error in something like this. So yeah, if like or not like whole, it's going to be something like this. So again we are getting some runtime error. Overflowed. Why we are not getting that error in Sublime? Why we are getting error? Let's debug this thing and see out I comma left comma right comma. Yeah, left is -1, the right is 3. And what is n? N comma t also. 3 minus, we can say. So left plus right minus I. Left, what is left? Left is -1. -1 plus right minus I. And I is 3. 3 minus 3 is going to be 0. Left, right is going to 3. 3 minus I. 3 minus 3 is going to be 0. And the left is going to be -1. So yeah, how we can do this? So like, so yeah, this can also be a 0, I think. So we can say, we can do something like this. Temp equal to max of temp comma 0. So yeah, it's working now. So let's try to remove this cout statements, and then again try to submit this thing. So yeah, you can see like this is working fine and it beats 100% of people. So yeah, so like this value can be like because we are taking like left can be a -1 and like a range -1 and a range +1. So in that case, if it's going to be a -1, so we are taking the 0 value, because for the 0 value the DPFI is going to be a 1. So because the 1 is possible for everything. So yeah. So, but in case of, I think it becomes 0, dp of going dp of I become 1. So yeah, so in that case this thing will not work because in range it's going to be out of range, I think. So yeah, this is pretty much for today. I think like it's too much too late to solve this problem. So we will solve this problem to by like on tomorrow. Like yeah, what is the problem? Like this problem. So yeah, so now the problem is going to be the same. Only we have to do something like we have to instead of returning the maximum length substring, we have to return the palindromic subarray sum, like a maximum possible sum, can the value be an active? So yeah, as the value can be a positive only, what we can do, we can simply like for every position we know them, but what is the maximum, like you can see yeah, here we know at every length what is the maximum subarray possible. So we will try to, like, because the value is positive, we will try to check for like maximum subarray for everything, like starting at this one, starting at this two, three, four, two, and everything. So if it is going to be a, like, what we can say, if it is going to be a same, then we have to check for the maximum subarray sum. So yeah, so I think it's going to be a same. So let's copy paste this code and try to do this thing. But I think what we can do. So yeah, let's try to solve this now only. So yeah, the function name is getSum. So we can simply remove these things. This class, yeah, this thing and this class thing. And after instead of taking this string, it is going to be take a vector. I'm going to take a vector, return a vector. Uh, it's going to be a vector and the so instead of adding this value, we are going to add some value infinity. We can say infinity, and we are going to add infinity, and let's define infinity as a hashtag define infinity equal to int max, we can say, because like you can say the value are up to 10 raised to power 9, so we can define it as a infinity as a int max value. Yeah, so again it is going to be a vector int and s, and it is going to simply return our the maximum answer. So we have to calculate the prefix sum, we can say. What is string? Not, it is going to be a vector int t. Else I think everything should be the same. Yep. uh, so yeah, we can simply make some prefix array, and it is going to be a ll because the value are going to be a very huge, and so we can define here ll as long. We can say n comma 0. So it's instead of n, it is going to be a s dot size, we can say. For then we can simply do a for loop int I equal to 0, I less than s dot size I plus plus. If I equal to 0, then prefix of I value is going to be a, we can say, s of I, else it is going to be a
prefix of I is going to be prefix of I minus 1 minus 1 plus we can say s of I. Yeah, that's it. We get the prefix array, and after that we are getting the start and end for everything. So yeah, so like ll, we can say, we can define ll. Answer is going to be a, initially answer is going to be a 0. Mm, like total sum is going, like total sum is going to be a initially v of and, we can say, sorry, not v, it's going to be s of and after that if the total like we can say, then like if start is greater than, or we can say greater than 0, total sum minus is equal to s of start minus 1, and answer is going to be a max of answer comma total, we can say total sum. So we can simply return answer here. Let's try to run this thing. Again getting runtime error. That's this thing. Like we are just we just copy paste the previous code only, and even don't make a lot of changes. So why it is giving us? So what are the start and end values possible? Hmm, start and end. How end can be something like this? So yeah, it is going to be plus, I think. So now what are the value of start and end? So let's try it now.
Start at 0 and end is 1. Yeah, I think it's going to be a prefix of and. Sorry. Yeah, I think it should not work. It's working for mostly test cases. So yeah, it's also like we have to minus the prefix of that thing. So yeah, it's working fine. So let's try to submit this out also. We are getting wrong answer. What is the max palindrome in this? This is a palindrome that possible. I think can another palindrome possible? Yeah, this is palindrome 76, 76, 76. So yeah, let's print start and end. So in this the start is 0, 1, like 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, 4, 5. 76 plus 76, 152 plus 2, 154. Yep, 154 is going to be answer. Eh, But why it gets stopped? Uh, so yeah, so like like we have to not do maximize this thing, so we can skip this case because we don't want like a value must be a less than size. But in this case, we are getting start at 0 and end at -1 for 10, 10 only. Nice. So let print I also. I is going to be a 0. In case of 0, so in case of like if the subarray length is 0, we can skip this thing. So yeah, let's try to submit it now. Hmm. Is there any new console we are using something? Yeah, it was the only log. So yeah, I think it is working now. So yeah, so now we have so today also we solved three problems, but we not able to solve the contest problem. So yeah, so tomorrow we will try to solve like a one contest and one problem also. So and also I am thinking of so from today I am going to start the system design also, and also I am thinking of like a making a making a project in a Node.js. So I am thinking of making a project something like it's a like you can say like a platform like a Udemy. So we are going to build a platform like that. So for that we are going to use a text we are going to use a Node.js and TypeScript for that, and also going to do like we are going to make a different type of microservices. So yeah, so like as we are also as I am also learning the system design also. So in that project, all my system design knowledge will also use. So the main idea was that like a where there can be a teacher in our platform. A teacher teacher can add a courses, different type of courses, like a video courses, that is going to a video courses. And after that a student can buy that courses, and they can watch that videos. So the main learning in this is going to be firstly we are going to be use the microservices architecture. Like for authentication we are using a different microservice. Then for, we can say, uploading video, we are going to for video processing, like because a teacher can upload, like if teacher is going to upload a video, they are going to upload only one video called let's say they upload the 4K quality video. So now we have to make a different bit rates for that video, like 730 320 360, 420p, 180p, 720, yeah, and 4K also. So we so that according to the network speed of a user device, so we can download different chunk, so if the initially the user login user start watching the video, so initially user network was very slow. So we will fetch a very low quality chunk, we can say 360p or 720, so that initially start of the video will be fast, but it can maybe a blurry. Like you can also see in a platform like Hotstar or any other, whenever you load a video, the first few seconds, like 10-20 seconds, will be a something some blurry thing, and after that the quality goes up to as I have 4K, according to the network's bandwidth of our device network. So yeah, so we have to do like a chunking thing in that, so that for a teacher can simply upload the video, so in the background we can do something like chunking and check if the content is good or not. So for that we will use Kafka for processing, because we have to yeah, this processing can be async. So we are going to so in this project we are going to be learn this processing also, Kafka also, how Kafka handle different types of thing, only once delivery, and yeah, this that kind of thing. And in the authentication also we are going to make we are going to maintain different session, as of now I am thinking of we can like a user can log in into different a five up to five different devices. So yeah, whenever user try to log in our six devices, we will show the list of the devices where the user is currently login, so we can also track that thing also. And also for analytics, so we are going to track everything like analytic things also. So yeah, so for the backend we are going to write like every part of codes by I am going to write everything by my own, like will not use AI to directly write the code. Yeah, we can use AI we will use AI to ask like is this code is correct or not, like that kind of thing. But not going to use directly AI in our code editor for backend. And for front end, I am going to mostly be vibe coding the front end part, because I don't like front end. So yeah, so in that we will learn different things, like how microservices architecture work, etc. kind. And also for internal microservices, talk like if the one microservice want to API call to another, so for that we are going to use gRPC. So yeah, so in which we also learn about gRPC. So in gRPC what happened, we don't do something like a simple HTTP call, but we do some in the internally it's something like also HTTP call only, but they follow proto buff kind thing, in which the data is data is in its compressed form, like we can say a binary form instead of a JSON. So that become pretty much fast than a traditional HTTP call, simple traditional REST API call. So yeah, so I am also thinking of making a whole series in which I am going to make this project from scratch only by doing live. So yeah, let's see when I will start that thing. So yeah, that's it for the today video. So hope you enjoy this video. Thanks for watching this video.